Alright, boys and girls, we are ready for lesson 4. Our objective is students will continue to work on our understanding of equal parts. Today we will partition circles and rectangles into equal parts and describe those parts as halves, thirds, or fourths. I must say, we have really started to become strong fraction wizards. And what are fractions again? Well, let's review. Fractions represent a part of a whole, right? We have the numerator, which represents the part, and the denominator, the number on the bottom, which represents all the parts that make up the whole. Let's take a look at this triangle that we have in front of us. We see that it's divided into two equal parts. Therefore, we have two halves. Do we have thirds? No, we don't see the triangle split into three equal parts. Do we have fourths? No, we don't see the triangle split into four equal parts. I'm not even sure if we can do that. That's something that we would have to investigate. Moving on. So let's take a look. Oh yes, here we go. So as we discussed, we can also take a look at this other shape, which is a rectangle. We notice that the rectangle is divided into two halves. Again, this can be represented as a fraction known as 1/2, where the 1 represents the part and the 2 represents the whole. Moving on. So let's focus today on rectangles. The rectangle is very unique in that it can be partitioned in several different ways. We know that a rectangle has 4 corners and 4 right angles. We also know that it's different from a square because it has 2 pairs of parallel sides and they are of different lengths. In each pair is of a different length. Let's imagine that we took a sheet of paper and starting with the first one, we just divide it in half across the middle, right? 2 halves. Let's say we then took our rectangular sheet of paper, and then divided diagonally. What are we left with? Two rectangles that make up. I'm sorry. Two triangles that make up the rectangle. So we have two halves using two triangles. Another way to create halves using a rectangle is to split it across, going horizontally. We can also divide the rectangle into thirds. We can either divide the rectangle into three equal parts going vertically or horizontally. In the last one, even though it is divided into three parts, are they equal parts? No, therefore that it does not count. Again, we can really do a whole lot with the rectangle. If we wanted to create eighths, right? 8 equal parts. We want to think about how many different ways can we partition a rectangle into eighths. And how do we know that we're creating eighths, right? So that's important to consider when we are partitioning any sort of shape equally and whenever we are thinking about fractions, because fractions are dependent on creating equal parts. So that's something to ponder. That's something I'm not going to go over with, but you can experiment on your own how to partition this rectangle into eight equal parts showing different ways to create eights. So now let's take a look at the circle, right? What is this? What do we see? We see a pizza. Why do I have a picture of pizza? Because the pizza represents the shape of a circle. And traditionally, when we buy pizza, it's split into 8 equal parts, right? Well, I'm sure that's not the only way that we can split a pizza into equal parts, right? We can also split it into halves, which is over here. We can also split it into thirds, fourths, fifths, sixths, sevenths, eighths, nines, tenths, 11ths, and 12, right? So as we can see, splitting the circle into equal parts, we can just continue to split them in as many equal parts as we want to, but notice as the more that we continue to split the circle, what happens to the parts? Well, we notice that the parts are getting smaller. So we notice that, well, let's take a look at these two halves, right? We're just looking at one half, right? This one half is, as we can see, larger than this 1/3. And then we can see that this 1/3 is larger than this 1/4. So it's interesting how as we continue to partition a shape more and more, what do we notice about the parts? Well, the parts get smaller. Now I want you to challenge yourself, okay? Since we can find geometric shapes all around us, what kind of fractions do you notice around you? How could you describe them? Something that I want you to think about and explore as we continue to do work today.